Hello, thank you for watching this video. So, on this video, I'll be doing question 4 of November 2021, question paper mathematics paper 2. And this is analytical geometry involving cycles. So, I'm going to read the question 4 statement and then answer the questions that follow. So, let's go. They are saying, in the diagram, the cycle centered at N passes through A and C. B, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis. CD is a tangent to the cycle at C, and CD is equal to 6 units. Let me read this thing again. They are saying, in the diagram, the cycle centered at N passes through A and C. B, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis. CD is a tangent to the cycle at D, and CD is equal to 6 units. No problem. So, here is the situation here. So, we have this circle here, the orange part, and have this center end, which is that one. Not a problem. So, they are saying to us now, our circle passes through A and C, as you can see there, right? And then they tell you that B, E, D, and C, they form a what? They form a parallelogram. Let me repeat this thing again. You have the circle, the orange circle here, and have the center end, which have the coordinates -1 and 3. This is not a problem. They tell you that B, C, D, and E are joined to form a parallelogram. This is a parallelogram, what you have here. Not a problem. So, they went on to say, what are they saying? They went on to say, your parallelogram, which is your B, C, D, E, is a parallelogram, right? They say that your BE is parallel to the x-axis. So, this BE of yours is parallel to the x-axis, right? So is that side. It is parallel to the, because if you have a parallelogram, this side is parallel to that side. So if this side is parallel to the x-axis, so if this side is parallel to the x-axis, so is that side, because they're both parallel, right? So you have you have this line BE parallel to CD, and you have CD parallel to the y-axis, so the x-axis. That means your CD is also parallel to the x-axis, right? No problem. And then they also saying that now CD, which is this line that is parallel to the x-axis, this line that has a parallel, this line that is parallel to the x-axis is a tangent to the circle at C. So this line CD is a tangent to the circle at C. No problem. And CD is equal to 6 units. That's all they told us. Let me try to repeat this thing again fast. So you have this orange circle that you can see here, right? So this orange circle has the center N. No problem. And the orange circle passes through C and A, as you can see there. No problem. They also want to tell you that this quadrilateral that you can see here, B, C, D, and E, is a parallelogram. You're told that it is a parallelogram. This side parallel to this side equal to this side parallel to this one, this side equal to that side. So this one is also 6 units, right? If you want to, you can just say 6 units. No problem. And then they also want them to say that this side BE here is parallel to the x-axis. What that automatically means by transitivity property, this one is also parallel to the x-axis. No problem. I think we're done. And these two sides, BE and CD, have lengths of 6 units. I'm happy with that one. So, I'll go to the first question. So, 4.1. They're saying write down the length of the radius of the circle. So, they want us to write down the length of the radius of the circle. No problem. So, what is the radius? So, a radius is the distance measured from the center of the circle to the circumference of the circle. So, here, we have this point here, and many points around the circle. So you have this point here and many points around the circle. So the distance from this to the circumference of the circle, you can do it from here to there. This is your radius because you have these coordinates and you have those coordinates over there. That means you can find the distance from the center to the circumference, which is the radius, right? So your D, the distance, what is this? This is 4.1, right? The distance of what? The distance of NA from the center to the circumference is equal to your radius. So if you find this distance, you'll be fine. You know your distance formula. Find the coordinates of N is what? -1 and 3. The coordinates of A is -1 and -1. Right? So one can see that this is a vertical distance between 2 points. So the distance NA, which is equal to R, is equal to what? It's equal to 3 minus 1, which is equal to 4 units. So your length of the radius of the circle is equal to 4 units. You can use the distance formula. It will come out the same. You know your distance formula. So D of NA is equal to the square root xn minus xa all squared plus yn minus ya all squared. So this should give you the same answer as this one, which is this. This is the vertical distance because the only change is in the y direction. No problem. So we're done with 4.1. So let's go to 4.2.1. What are they saying at 4.2.1? They are saying calculate the coordinates of C. So they want us to find the coordinates of C. What is C? C is this point here. They want us to find the coordinates of C. So how can you get this? So we're told that the line BE. We're told that BE. So I'm doing 4.2.1. We're told that BE is parallel to the x-axis, or the line y is equal to 0. The same thing. Right? And you're also told that your BE, or you're not told, but you know that your BE is parallel to your CD because you have a parallelogram. So this you were told. This you know because you have a parallelogram. These are opposite sides of your parallelogram. So this is parallel to that. So your BE is parallel to the x-axis and your BE is also parallel to CD. That means CD is also parallel to the x-axis. So what that tells you is that your CD is parallel to your x-axis. So the x-axis, the orientation or the shape of the x-axis, the x-axis are horizontal. The x-axis is horizontal. That's what we know. So which means this line is horizontal and this line is horizontal, because if they are parallel, if these three lines BE, x-axis and CD are all parallel, they have the same orientation, which is this line, x-axis, BE and CD are all parallel. They have the same orientation. That's what parallel means. It means that they have the same orientation. What that implies, it also means they have the same gradient. Because all lines with the same orientation will have the same gradient. No problem. So we get that this is horizontal. So this line is horizontal here. This line is horizontal. And we're told that this line CD, we're told that CD is a tangent to our circle. At where? At C. We're told that this line CD is a tangent at C. And we know that if CD is a tangent to the circle at C, the line CD, or actually, the tangent, the line of tangent is perpendicular to what? To the radius of a circle. We know that the tangent, the tangent line is perpendicular to the circle. So if this is horizontal, which is this is vertical, so that perpendicularness is preserved there. Because if this is horizontal, this should be perpendicular, this should be vertical in order for the perpendicularness to be preserved. So that means this line CN is vertical, so which makes it parallel to this guy over here. So if from here to here is 4 units, right? From there to there is also 4 units. So what that means, if you want the coordinates of C, you just go 4 units upwards. So the coordinates of C, they should be, because if you go vertical upwards, right? If you go vertical upwards, the x value does not change, because along this line, the x value remains unchanged. In a similar way, the y value, the x value remains unchanged on the y-axis, as you can see here. Along the y-axis, x is 0. So along this line, we know x should be equal to -1 everywhere on this line, no matter how long it is. So the coordinates of C, x value will remain unchanged to be -1, and the y value, it was 3 units, so you're adding 4 units upwards, so it should be 7. So these should be the coordinates of C. Or the other way you can look at it, you can see that you have a vertical line from C to A, and N is the midpoint between C and A. N is the midpoint between C and A. So now you have the coordinates of A, the coordinates of the midpoint. You want the coordinates of the other point that gives you the small midpoint of N. So I'm going to do this question another way. So I'll say, okay, I have the x coordinate of the midpoint. I have one of the x coordinates that gave me the midpoint. I want the other point to which N is a midpoint between A and C. So what do? You know that you say, okay, x coordinate of the midpoint is equal to x1 plus x2 all over 2. And the y coordinate of the midpoint is equal to y1 plus y2 all over 2. So, but the x coordinate that you have is for N. So the x coordinate of N is equal to the x coordinate of C plus x coordinate of A all over 2. And the y coordinate of N is equal to y coordinate of C plus y coordinate of A all divided by 2. So the x coordinate of N is what? The x coordinate of N is equal to -1, so you put a -1. It's equal to x coordinate of C, which is what you're looking for, plus x coordinate of A. What is the x coordinate of A? X coordinate of A is equal to -1, all divided by 2, right? And the y coordinate of N, what is it? It's 3, is equal to y coordinate of C, which is what we're looking for, plus y coordinate of A. What is the y coordinate of A? Y coordinate of A is equal to -1, all divided by 2. So you cross multiply, solve for this. This times that, -2 is equal to xc minus 1. And cross multiply here. So 6 is equal to y of c minus 1. So for x of c, the x of c is equal to -2 plus 1, which is -1. And the y of c, transpose this to the other side, 7 is equal to the y of c. So your coordinates of c are still -1 and 7. This is another way you could have looked at this. So we're done here. We move to 4.2.2. Or 4.1.2, sorry. So the coordinates of c here are -1 and 7. Put the information in, you never know. -1 and 7. But we knew already that the x coordinate was going to be 1 because it's along this vertical line. So along this line, the x value should remain unchanged. No problem. So, actually it was 4.2.2. I was not wrong. So, let's move. Now, we're doing 4.2.2. They're saying now, calculate the coordinates of D. They want us to calculate the coordinates of D. So here is D, sitting here. This line is horizontal, parallel to the x-axis, right? So from here to there is 6 units, right? From here to there is 6 units. So we don't have the coordinate of D, x and y for D. But if this thing is horizontal, right? For example, here, we know that the x-coordinate, we said it remains unchanged. It's -1 here. And here, this is the origin is 0. The distance from here to here, we know it's easy. It's 1 unit. So the distance from here to there is going to be 1 unit. The distance between these 2 points. Because from here to here, it's just 1 unit. But you're at -1, right? You're at -1. You're told that the distance, because to move from here to this is 6 steps, is 1 step, which is this 1 step. That's why the distance is -1. And the coordinates of this point is 0 and 0. So which means that x-coordinate that was 1, it's more like you added 1 unit to it and got 0 there. But here, look at this. The coordinates here is -1 and 7. Look, if you move to that side, since this is horizontal, the y value will remain unchanged because you are not making any change in the y direction. You're only moving horizontally towards D. That's what you're doing. You're moving horizontally towards D. So, whatever D is, you already know its y value will not be changed. It will not be changed. It will remain to be 7 because you're moving horizontally. Because if you're moving horizontally, the y value does not change. Only the x value changes. As here you're moving vertically. When you're moving vertically, the x value was unchanged. So if this line here is called, the line y is equal to 7. So along that line, y is unchanged. It will remain to be 7. Right? So now, if you want to know the x value, you should just move 6 steps from this point to that point. If you move 6 steps from this to that, what you'll find is okay. It will be, you're moving from the coordinates of -6 and 7, right? You know that the 7 will not change, the y value will remain unchanged. But you will have to move 6 units to the right. So you increase this thing by 6 units, and this will become 5. So the coordinates of D is 5 and 7. I'm not sure if this makes sense. Because this thing is horizontal. So you just move 6 steps to this direction. If you move from -1 and you move 6 steps to the positive direction, you'll end up at 5. So this x-coordinate here should be 5 units. So your coordinates. So what you're saying now is that your coordinates of D are 5 and 7. We're done. We'll move to the next one. 4.2.3. Okay, so now we're going to do 4.2.3. What is 4.2.3? They're saying calculate the area of triangle BCD. Calculate the area of triangle BCD. That's what they wanted to find. Where is BCD? BCD is B, C, and D. So it's this triangle over here. This triangle. Finding the area of this triangle. Over here. You want to find the area of this triangle. So, if you're finding an area of a triangle, so you know the area of the triangle. Area of the triangle is equal to half base times the height of the triangle. Right? Half base times the height of the triangle. Or maybe to be specific, times the perpendicular height of your triangle. So, triangle comes in different shapes, right? But Here are the three shapes that they come in. So you can have a right angle triangle like this one, right? Here is it. This is A, B, C, where 90 degrees is here. Or your other triangle can be like this. Let's say it's A, B, C, D, E, F. Or the triangle can be something like this one. Okay, let me move it a bit down. A, B, C, D, E, F, G, H, I. So, this is the nicest possible scenario, right? Provided that you have all the sides. And I'm assuming you have all the sides here. So, your base is what your triangle is sitting on. And this is the height of your triangle. This is your base, this is your height. So your triangle will be half, your area will be half the base times the height, which is this height over here. No problem, because this is your perpendicular height, which is this one over from here to there. This is your height, and this is your base over here. And here is your base over here. Where is your perpendicular height? It's this one from here to there. There is a perpendicular. You need to have this. So this is your height. So your area will be half base times perpendicular height, which is that one over there. Then things looks different here, because here you have your base to be this thing over here, right? But what is the height of this triangle? The height of this triangle is this one. If I were to produce or to extend this here, this is not the triangle, but I'm just producing the base of the triangle. The height of this triangle is this one over here. And if you look at it, it is perpendicular to the produced line from the base of the triangle. So this height here is perpendicular to this extended line from the base of the triangle. So this is your base from here to there. And that is the height of this triangle, which is this one over here. So your area will be half base times the perpendicular height, which is this base here, times the perpendicular height, which is not perpendicular, because if you look at it, this height is not perpendicular to the base of the triangle. It's perpendicular to the extension or the production of this line from its base. So this is your height of your triangle. So if you're looking at this triangle over here, which is this triangle over here, I would like my base to be horizontal as is those ones. So I'll take this part here to be the base of my triangle, right? And the height of my triangle is this one over here. So if I were to produce this to the side, so this will be the height of my triangle, this one over here. This is the height of the triangle. This is the base of the triangle, and this is the height of the triangle perpendicular to the base, too, because this thing is vertical upwards. So you're moving from a height of 2 to a height of 7. So this is, your h is called 5 units. The vertical height here is 5 units because you're moving from y, which is 2, to the y, which is 7. Because we know, I said along that line, y is 7, it's the same throughout. And your base, you're given that your base was 6 units. So if you want your area of triangle, what? BCD, right? BCD should be called half base. What is your base? Your base is that one, it's 6 units. Times your height. What is the height of this? From 2 to 7, it's 5 units. So it should be 5, right? So your area should be something along 15 square units. 15 square units. So your area, triangle BCD, is equal to 15 square units. And I think I'm done with 4.2. So I'll clear the board and then do the last part, which is 4.3. So let's go. Okay, so now I'm done cleaning the board. I've cleaned that old circle as well and redrawn this one so that the next question is much clearer. I won't need all the information from the previous question. So this will be enough. So I've redrawn it so that it's much nicer and it's clear what I'll be doing from here. So let's go. Question 4, 4.3, right? They are saying the circle centered at N is reflected about the line y is equal to x. M is the center of the new circle which is formed. The two circles intersect at A and F. Let me read this thing again. They are saying the circle centered at N is reflected about the line y is equal to x. M is the center of the new circle which is formed. The two circles intersect at A and F. So this is the circle that we were given initially, but remove the parallelogram so that it's much nicer and easy to see what I'll be doing with it. So they are saying this circle here is reflected about the line y is equal to x. That's the first thing. And M is the center of the image of this circle. And the two circles intersect at A and F. So here's what happened. This circle here, this is 4.3, is reflected about line y is equal to x. What is this? This is a straight line, you know it. It's y is equal to x plus 0. So it's a straight line that passes through the origin. Right? The straight line that passes through the origin, which this line passes here. Right? Passes here. And they're saying now the line, the circles intersects at A and F. So what that means is you are reflecting about this line such that it passes through A and F. So here's your F somewhere here. So the point A and F, right, are the points where your circles intersect. So let me do this. Let's say you have a circle here and another circle and another circle here. So these circles intersect here and here. These are the point of intersection, this point and that point over there. Right? This is the line segment joining the point of intersections. So you have a similar situation here. If you reflect about this line, y is equal to x, here is what happens. This, let's suppose that you had a mirror, right? Let's suppose that you had a mirror and you put your mirror here. You look at this side and see what you will see. This part that you will see will appear on the other side of the circle, but bent on the other direction. So when you look at the mirror like this and looking at this thing here, because that's what you do with the reflection. If you're looking at the mirror, what you see there is a reflection. So if you are reflecting this circle about this line, you must look at it from this side and say, okay, this part will be on this other side. So this is how it will look like. This part will be like this. So this is a reflection. So if this is the minor arc AF, this one. This is the minor arc AF. This is the minor arc AF. Here, what you see here is the reflection or the image of the minor arc AF. This is the image of the minor arc AF. Same mirror, but looking on this other side now. So it will continue to that other direction. So this is the reflection. This is how your reflection will look like. It will look like this. So what you do when you reflect, you apply this transformation, your x and y coordinates. They become what? Y and x. That's what happens. So you reflect about this point, about this line. Then what you need to keep in mind is that, look at this line, its coordinates, x is always equal to y. So this point A over here, this point A, with coordinates, A is called 1 and minus 1. This point here, minus 1 and minus 1. It lies on this line. It lies on this line. because the points on the line y is called x, they're always x and x. Because they're equal. X and y are equal all times on this line. So this point A, it falls or lies on this line. That's why I joined this line such that it passes through this point because its coordinates are the same, which means it lies on this line y is equal to x. That's what we need to know. No problem. So now, I think I'm done with this question. I can just wrap up. So now, what I did, I was given this point here, this circle here, right? And then I was told that I should reflect it about the line y is equal to x. Here is this line y is equal to x. I reflected the circle and it looks like this now, or similar to that. No problem. What else did they say? They say M is the center of the newly formed circle. So M maybe is somewhere here. Because if it was there, it should be somewhere on this side. No problem. What else? They say the circles intersect at A, they intersect here, and there at F. I'm done with this. So I'll go to the questions. 4.3.1. Calculate the length L and M. They wanted to calculate the length and M. So this is 4.3.1. 4.3.1. Calculate NM. Right? So the distance of NM is equal to what? It's going to be equal to the x coordinate of n minus x coordinate of m all squared plus the y coordinate of n minus the y coordinate of m all squared. So we have the coordinates of n we're given to be minus 1 and 3. The coordinates of m, not so much, xm and ym. We don't have them. But what we know is that we reflected about the line y is equal to x. And if we reflect about this line y is equal to x, we apply this transformation. Your x and y become y and x. So if this was your n, this will be your image of n. This is what n will look like after being reflected. So, which means your n was minus 1 and 3. So the image of n, which is m, right, will be, you will swap these things around like you did here. So the coordinates of the image of n will be 3 and minus 1. And that image of n is now called what? It's called m, which is 3 and minus 1. So image of n is m. Because n was the center of the old circle. The new circle, its image was n, but it's called m. No problem. So now you will be able to find the distance. So let's find the distance, nm, which is equal to x coordinate of n. What is the x coordinate of n? X coordinate of n is 3 minus x coordinate of m. Oh, sorry. X coordinate of n is minus 1 minus x coordinate of n, which is 3, all squared, plus y coordinate of n, which is 3 minus 1, all squared. So the distance of nm is equal to the answer to this thing. So let me punch it down and see what is the answer that we get. So it's minus 1 minus 3 all squared plus 3 minus 1 all squared. So the answer that we get is equal to 4 over 2 units. Right? No problem. Then we move to the next question, which is 4.13.2. What are they saying at the next question? They are saying calculate the midpoint of AF. So they want us to find the midpoint of this line segment AF here. They want the midpoint of this line segment. So how do you go about this? You need to remember your geometry, right? So your geometry states that, on your geometry you might remember that a line segment joining the centers of two intersecting circles, right, is perpendicular to the line segment joining the points of intersection. So let me write that down. I'll say a line segment joining a line segment joining two centers of intersecting circles. Is a perpendicular bisector to a line segment joining the points of intersection of the circles. I hope this makes sense. What I'm trying to say is that a line segment that joins the centers of the two circles, because this is the center of the old one and this is the center of the new one, which is 3 and -1. A line segment joining the centers of two intersecting circles. So this is a line, you have circle 1, the red one, you have circle 2, the blue one, right? This line NM here is a line segment joining the centers of two intersecting circles, right? No problem. So what you need to know is that a line segment joining the centers of two intersecting circles is a perpendicular bisector to a line segment joining the points of intersections of those two circles. Let me repeat this thing again. It's all the thing I've written here. I'm saying a line segment joining the centers of two intersecting circles is a perpendicular bisector to a line segment, right? Is a perpendicular bisector to a line segment joining the points of intersections. That's what I'm trying to say. Which means this line meets this one at this line NM is perpendicular to AF and meets it at the midpoint. Which means this is the midpoint of this, and that. That's what I'm trying to say. So now, what you need to find that midpoint, and those will be the coordinates of your midpoint AF. So how do you do that? So this line is the line which you're reflecting by. It's the line y is equal to x, right? It's the line y is equal to x plus 0 must say. The gradient of this line is equal to 1, right? But since this one is perpendicular to this one, you know the product of the two gradients is -1. So the gradient of NM times the gradient of NM times the gradient of AF is equal to -1. Why? Because NM is perpendicular to AF, right? Which is what I just said here, that a line segment joining the centers of two intersecting circles is a perpendicular bisector to a line segment joining the points of intersections of those two circles. So now you want the gradient of NM here, or you can just simply calculate it from there. But to do that, you say, okay, NM, which is gradient of NM, which is what I'm looking for, times the gradient of AF, which is 1, is equal to -1. Then from this, you'll find that the gradient of NM, I don't know why I write A and B, of NM is equal to -1. So what we can do with this gradient, we can find the equation of this line and find the point of intersection, which we know that is the midpoint of AF. So let's find the equation of the line. Y is equal to mx plus c. Which line? It's a line NM. So we take one of the coordinates. Let's take n, which are the coordinates -1 and 3. So 3 is equal to 1, which is the gradient, times x, which is minus 1. Actually, it's minus 1 gradient, because there it is, plus c. So 3 is equal to 1 plus c, which means the c is equal to 2. Therefore, the equation of nm is y is equal to minus x plus 2. But then you want this point there, which you know that this line is a perpendicular bisect to this one. So that point of intersection is the midpoint of AF. So you say, okay, y line y of nm is equal, you want where it is equal to y coordinate of AF, which is that point of intersection. So your minus x plus 2 is equal to x. So you solve for x. 2 is equal to 2x. You transpose this to the other side. Divided by 2, divided by 2, your x equal to 1. But I said the coordinates are always the same. Or maybe you can substitute your x value here, there. You'll find that your y is equal to minus 1 plus 2. Your y is equal to 1. So the coordinates of the point of intersection, which is the midpoint, are 1 and 1. So that's how I looked at it, and I hope it does make sense to you, as it does to me. Thank you for watching. Cheers.